This is Dr. Taposh, and as we are continuing our educational series and we are going in the depth of understanding the biomechanics of supraspinatus tendinitis and the pathomechanical changes while altering any type of mechanism of the glenohumeral rhythm. So today one of the most important biomechanical aspects we will understand from this simple concavo-convex rule and alteration of that, how it makes the supraspinatus tendon to go for the impingement. So the first to understand that, we need to understand that what is the concavo-convex rule. So as we know, the glenoid cavity which is concave in nature and the head of the humerus which is convex in nature. And as per the law, when this convex surface it moves over this concave surface of the glenoid cavity, it normally it rolls upward, but it slides downward. Again, whenever the convex surface, that's the head of the humerus, moves in the concave surface of the glenoid cavity, it rolls upward to gain the abduction range of motion, but it slides downward. Now, why these things, why these biomechanical changes is happening during this rolling and sliding of the head of the humerus in this convex nature? The reason is, if there is, this is the acromion process, and whenever the head of the humerus moves upward as a rolling and slides downward, there is a enough amount of subacromial space. But if this head of the humerus does not roll properly, what is to happen? The coracoacromial, the space, the coracoacromial arch is used to have a reduction, and reduction of this arch and the space reduction of the subacromial region, there is a chance of having a impingement of the supraspinatus tendon. So what we understood from this mechanism? A simple concavo-convex rule is very important to understand. The orthokinematics of this is very important to gain a proper abduction range of motion, and if the head of the humerus does not slide properly, then there is a huge chance to have a supraspinatus tendinitis. So what's happening exactly? Exactly, whenever we are doing this abduction, the head of the humerus as it is rolling, it's rolling upward, but it's to slide downward. So the space over here it is maintained, and that mainly purely happens during the abduction range whenever someone is to do the pure abduction, but that does not happen in a scapular plane. And that is the reason whenever we do any movement in a scapular plane, there is a chance of having an injury. So with the easiest example, I will make you understand that if we do a abduction range of motion, which is easy as a part of a mechanical advantage, but if I lift any object, if I do any movement in a part of a scapular plane, which is very difficult, and also there is a chance of having a impingement if you do any movement. Now take an example. If I am lifting a weight in a 0 to 90 degrees of a pure abduction range, this is easy to lift, but if you lift in this plane, this is was a scapular plane, it is difficult. And why? The reason is, in a scapular plane, whenever in a abduction, normally the head of the humerus is to roll upward but slide downward, but in the scapular plane the sliding downward mechanism of the head of the humerus does not happen, and that makes the reduction of the subacromial space and a chance of having a impingement. So by this we can easily understand that how the simple biomechanical reasoning, the simple concavo-convex rule is very important as a part of orthokinematics of the glenohumeral motion, and any alteration of this may go for a impingement of the supraspinatus tendinitis. Coming to this understanding of this, we came to know this simple biomechanics, as in the last class we have understood about the scapular motion and the relation with the supraspinatus tendinitis, and of course this orthokinetic motion. So there is a several mechanism used to happen at a single way when there is a injury. So any alteration of the biomechanical changes makes the alteration in the whole orthokinematics, and that makes the pathomechanical changes. So I hope you will understood this biomechanics. We will go little more depth. We will learn few more important part of the biomechanics to understand the shoulder glenohumeral motion. I hope people understood. Stay tuned with us to learn with us. Thanks once again, and don't forget to subscribe our channel. Thank you.